Hello and welcome back to the lecture on applied econometrics. So in the previous lectures we have been talking about different types of probabilities. We learned these concepts. Now in this lecture we will introduce the concept of probability distribution. Now before I get into probability distribution, it is important for us to again go back to the concepts that we have learned, and one concept that we have learned is random experiment and associated variable, random variable. Now recap, what is a random experiment? So when we said random experiment, or whenever we use the term random, so we usually refer to the fact that there are certain chances involved, there are certain uncertainties involved. I really do not know the outcome of that experiment. So that is when I call an experiment a random experiment, or the variable which is associated with that experiment, we call it a random variable. So that means I do not know the outcome of the experiment, or I do not know all the possible results that I am going to get for that random variable. Now when I talk about these random variables, one thing we have to remember, and that is we are talking about uncertainties, but we never talk about equiprobable or equally likely chances. So by random does not mean the probabilities are equal for all the events. Sometimes it is confusing, we mentioned it before. It only means that there are certain uncertainties involved. So what are the examples of random variables? Random variables could be something like, let us say I am talking about temperature distribution. Okay, so I do not know the temperature that we are going to have in say next 1 month. So I am going to predict the temperature, so that is a random variable. Or I am going to throw a dice, or I am going to throw a coin, or maybe a couple of dice and couple of coins, and I do not know what outcome I am going to get until and unless I actually do that experiment, I actually run that trial, right. So that is why this is called random variable. Now there are two types of random variable, one is continuous, another is discrete. So let me write it down, discrete and continuous. So think about one example of a discrete random variable and another example of continuous random variable. So we have already spoken about it. So by discrete it means that you can actually get exact value of a particular event. So what I mean by that, for example, if I talk about throwing two dice or maybe tossing two coins, so we always get those outcomes, right, and we always get a specific probability to that particular event. Say I want to get a probability for say 2 head, so I will get a probability for that. Whereas for continuous random variable, it's basically we can have a continuum of values of the variable. We do not really have we cannot really specify probability for a particular value, and I'll just explain that. So let's say I'm talking about temperature, right. So when I talk about temperature, so temperature could be any temperature, like let's say the temperature in Kharagpur could be anything between 10 degrees Celsius to 40 degrees Celsius. Now it can be, let's say we can say today's temperature is 30 degrees Celsius, but when you measure, when you actually see, it might be 30.001 degrees Celsius, or it might be 29.998 degrees Celsius. So it's very difficult to get exact temperature, because when it's basically a continuum of values, you can actually have a little bit of fluctuation, and for every different values. So in this range 10 degrees Celsius to 40 degrees Celsius, you can have infinite number of values if I consider this kind of values. So you can go on like 99998 degrees Celsius and so forth. So that way you really do not have, if I take any specific value, you really do not have a probability assigned to it, because of the fact that for any particular value like this, the probability is almost 0. So we cannot really talk about probability for this kind of values. And that is why we will see for discrete random variable and for continuous random variable, we have to consider the probability distribution differently. Okay. So now we will come to the idea of probability distribution, but before I go to probability distribution, let me actually give an example. Let's say, and this kind of examples we have done before, let's say we have 2 dice, okay, and we are throwing these 2 dice. All right. So we know the outcome of the throws, right. So it can be a value from 1 to 6 for both the dice. Now I am defining a random variable, and that random variable x, let's say random variable x actually signifies the sum of values that you get from 2 dice. So, when you throw 2 dice, you get value, a specific value on each of these dice, and then you sum it up, and that is what our random variable is, that represents the sum of the values after you throw 2 dice. And let us say the values that you can get from, let us say, dice 1. Let me actually use a different color. It will always look good if you have many colors. Dice 1, and let us say I have another dice, and that is dice 2. Okay, and here I will, these are the values you can get, 5, 6, and for dice 2 also you can get these values 1, 2, 3, 4, 5, 6. Okay. Now, to get the get x, the sum of the values of 2 dice. So, what I will get here, so if I get 1 and 1, let me write down a different color, 1 and 1. So, I will get 2 here, 2 and 1 I will get 3, 4, 5, 6, 7, here I will have 3, 4, 5, 6, 7, 8, here I will have 4, 5, 6, 7, 8, 9, then I will have 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and then I will have 7, 8, 9, 10, 11, 12. So, I will have all these different values, which is basically representing the values of the different values that x can possibly take. Now, if I want to constitute, so from here I can very easily constitute a frequency distribution, and from there we will see the probabilities associated with each of these outcomes. So, let me do that. So, let us just count. So, how many 2's are there? How many 2's are there? So, basically let us say, let me actually create a new page. So, here I will, so the values of x here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, right. Now, if I go back and see how many 1's are there, from here you can count, you can see how many 1's are there. There is no 1, right. So, I can write this is equal to 0. How many 2's are there? I have only 1 2, okay. And how many 3's are there? 2 3. How many 4's are there? 3 4. How many 5's are there? 4 5's. How many 6's are there? 5 6. So, let me write these numbers down, okay. Yellow, 0, 1, 2, 3, 4. And what about 6? We had 5 6's, 5. And how many 7's are there? You will see we have 6 7's, 2, 3, 4, 5, 6. And then I will see 5 8's, 4 9's, 3 10's, 2 11's and 1 12. Okay. So, if I just write it down here, 6, 5, 4, 3, 2, 1. Okay. So, these are the frequencies I got. The frequencies, if I count the frequencies, so these are the number of frequencies, these are the number of times you can see this particular outcomes. Okay. Now, I want to calculate the probabilities. Now, I want to calculate the probabilities, and we know that there are altogether how many outcomes are here. So, altogether there are 6 and 6. So, 36 outcomes. So, n is 36. So, when I have n is 36, so then I will have probability values 1 by n, right. So, it is going to be, so there is no probability for 0. So, it is 1 by 36, 2 by 36, 3 by 36, 4 by 36, 5 by 36, 6 by 36, again 5 by 36, 4 by 36, 3 by 36, 2 by 36 and finally 1 by 36. Okay. So, these are the probabilities that you got, and if you add them up you will see it is going to be 1. So, basically if you add them up I am going to get 1 plus 2 3 plus 3 6 plus 4 10 15 21 and 5 is 26 plus 4 30 33 35 36. So, 36 by 36 is 1. So, our calculation is correct. So, what you have got basically, the reason we did this exercise is to sort of give you an idea about what is a frequency distribution or what is a probability distribution. So, for all these outcomes we kind of ran an experiment where we threw 2 dice and we got all these possible, we know all these possible outcomes, we have their frequencies, we got their frequencies and we also calculated the probability distribution. So, these are basically how you can see a probability distribution and a frequency distribution. Okay. Now we have to sort of, when we talk about probability and frequency, we have to sort of get some ideas clear, some basic ideas, and that is we will see, we are repeating, we are sort of encountering this kind of concepts, we have to clarify this kind of concepts time and again, and that is, we will talk about a double structure of variable and we are just going to come there. But before that, we have to sort of understand a fact that when you are talking about a frequency distribution and a probability distribution, certain things are different. Where they are different? So, when you are talking about frequency distribution, we are basically, you know, already sort of running the experiment, we are getting the results, right. We already have the results in our hand. So, in this case, we have sort of, you know, like constituted this sample space, is sort of under the paradigm of classical probability theory, where you really do not need to run an experiment, but you always know, given a certain condition, what are the outcomes going to be. But we will see in a while when you do another example, where there we will actually, you know, use some historical data to constitute the frequencies, okay, and then from there we will get the probabilities and sort of probability distribution. Okay. So, we will see that in details, but basically the idea is, when I talk about frequencies, we already have the numbers in our hand. So, when you already have the numbers in our hand, it means that you have run the experiment, you have got the facts on the table, right. So, you do not have to sort of think about a future potential distribution, you already have the numbers, and that is basically the difference between frequency distribution and the probability distribution. So, from frequency distribution you constitute the probability distribution, and that actually helps you to sort of for future events, or sort of to get the potential distribution, you sort of make a prediction from the probability distribution, and that is where these two are quite different. And in this next lecture we are actually going to talk about the differences between probability distribution and frequency distribution, and we are going to see with an example how we constitute a probability distribution from a frequency distribution. So, with that we end the lecture here, and in the next lecture we are going to see in details how the concepts are different.